Welcome back to the Explainer. Whether you've just conquered fourth grade and want a well-deserved victory lap, or you're gearing up for fifth grade and need a rock-solid foundation, you are in the perfect place. Today, we're building your ultimate science toolkit. We're going to do a complete refresher on the core concepts that dictate exactly how our physical world works, giving you everything you need to take your scientific understanding to the next level. Okay, let's dive into this. Here's the roadmap we're going to explore today. 1. Matter and its changes. 2. Materials and solutions. 3. Separating mixtures. 4. Forces and energy. And finally, 5. Simple machines. All right, Section 1. Matter and its changes. The building blocks of everything. Take a quick second and just look around you right now. The desk you might be sitting at, the glass of water you're drinking, and even the completely invisible air you're breathing, literally all of it is matter. Matter is defined as anything that has mass and takes up space. It is the universal rule for all physical stuff. It really doesn't matter what the shape, size, or color of an object is. If you can measure its mass, and if it occupies physical space in the universe, boom, you are looking at matter. Now, matter loves to switch things up and take on different forms, specifically 3 main states: solids, liquids, and gases. Let's think about how the tiny particles or molecules behave in each of these states. In a solid, like a wooden desk, those tiny particles are packed super tightly together. That tight packing gives solids a fixed shape and a fixed size that you can't just easily squish. Now, contrast that with a liquid, like water. The particles in a liquid are much more loosely packed. They flow freely, keeping a fixed volume, sure, but taking the exact shape of whatever cup or container you happen to pour them into. And then we have gases. Here, the particles have total freedom. They are spread far apart and bounce all over the place. Because of this, gases have no fixed shape or volume, which is exactly why gases, like the oxygen we breathe, are totally invisible to us. But matter doesn't always stay exactly the same. When it does change, it happens in one of 2 distinct ways. First, we have a physical change. This is when the outward appearance or shape changes, but the core identity stays exactly the same, and it's usually really easily reversed. Think about freezing liquid water into ice cubes. It might feel like a hard solid now, but hey, it's still just water. On the other hand, we have a chemical change. This happens when an entirely new substance is formed, and it cannot be easily reversed. Think about burning a piece of wood in a campfire. It turns into ash and smoke. You can't exactly unburn a log, right? The matter has been fundamentally changed. Moving on to Section 2, Materials and Solutions, mixing things up. It is time to level up our toolkit. What actually happens when we take different types of matter and start mixing them together? Well, we get things like a solution. A solution is a uniform mixture where a solute dissolves in a solvent. To really picture this, imagine it's a super hot summer day and you are making a fresh glass of sweet lemonade. You know that perfect blend where the lemon and sugar are mixed so evenly into the water that you can't even see the individual parts anymore? That beautifully uniform drink is your solution. Let's break down the 2 main players in any solution, and we'll use salt water as our example. First, you have the solute. This is the substance that's being dissolved, like the salt. Notice how it's usually present in a much smaller quantity. Then you have the solvent. This is the substance doing the actual dissolving, like the water. The solvent is almost always present in a much larger quantity. In fact, water is so incredibly good at this job, scientists literally call it the universal solvent. Now, what if you're in a total rush to make your solution? Here are 4 rapid-fire tricks to speed up the dissolving process. Number 1, stirring. Physically mixing things with a spoon helps them blend incredibly fast. Number 2, heating. If you pour hot coffee over sugar, the heat breaks down those sugar crystals almost instantly. Number 3, increasing the solvent quantity. Adding way more water just gives the sugar way more room to spread out and dissolve. And number 4, breaking the solute into smaller pieces. Crushed up bits of sugar will dissolve way faster than dropping in a giant solid sugar cube. So here's a fun question for you. Can a gas form a solution? You might naturally think of solutions as just solids like salt or sugar dissolving into liquids. But the answer is an enthusiastic yes! That is exactly what makes your favorite soda pop fizzy. Carbon dioxide gas dissolves right into the liquid water, proving that gases can absolutely be part of a solution too. Section 3, Separating Mixtures, Taking Things Apart. If we have the skills to mix matter into solutions, a true science master also needs the tools to pull them back apart. Let's learn how to do exactly that by imagining a glass of muddy water straight from a puddle. How do we get that dirt out? Well, step one is sedimentation. If you just let that muddy water sit completely still, gravity will naturally pull the heavy, solid dirt particles down to settle at the very bottom. Step two is decantation. This is where you very carefully pour off that clear liquid top layer into a new cup, leaving the heavy dirt at the bottom behind. And if you need the water even cleaner, step three is filtration. This is like using a strainer or a paper filter to physically catch and block the tiny remaining solid particles while the pure liquid flows right through. Gravity and a few simple tools are literally all you need to reverse a mixture. Let's move to section 4 and see how this builds. Forces and energy, making matter move. Okay, we know what matter is and how to mix and separate it, but how do we actually get it to move around? It all comes down to force. A force is simply a push or a pull that one object applies to another when they interact. This interaction is absolutely amazing. It can start motion, it can stop motion entirely, or it can change an object's speed or direction. Whether you are kicking a soccer ball away from you or pulling a heavy desk drawer open toward you, you are using the fundamental superpower of force. Now, there are several key types of forces we use or experience every single day. Some are contact forces, meaning physical touch is strictly required. For instance, muscular force comes directly from your body kicking that ball. Or frictional force, which is the physical resistance created when two surfaces rub together, like a rolling ball eventually slowing down on the grass. But then we have non-contact forces that act completely invisibly, like gravitational force, constantly pulling everything back down toward the Earth, or magnetic force, which can attract or repel certain metals from a distance without even touching them. So, the crucial point here is how force actually relates to work. In science, work is defined as the effort or energy used to move something or change its position using a force. But here is the trick, and it is a massive one in physics. If you use all your muscular force to push against a giant, heavy brick wall, and you sweat and grunt and push, but that wall does not move even a millimeter, scientifically speaking, you did absolutely zero work. Work only happens when your force actually causes movement. And to actually do that work, we need energy. Let's quickly compare the two main types of energy. First up is potential energy. This is stored energy because of an object's position or state, like a ball resting high on top of a steep hill, just waiting to drop. Then we have kinetic energy. This is the energy an object has because it is actively moving. Think about stretching a rubber band. When you pull it back and hold it tight, that is pure stored potential energy. The second you let it snap back, that energy transforms instantly into moving, fast-paced kinetic energy. So, where does all this energy come from in the first place? How does the sun provide energy to the Earth? Well, it beams down massive amounts of light and heat energy across space. Living things like plants use that light to grow, which in turn feeds animals and humans, so we have muscular energy. We even use amazing technology like solar panels to capture that light directly and convert it into electrical energy to power the screen you are looking at right now. Section 5, Simple Machines, our everyday science tools. For our final level today, we are looking at how humans invented brilliant tools to use force and energy to make our lives infinitely easier. We call these simple machines. These are basic tools that make work simpler, easier, and faster by using a very straightforward idea. When scientists say machines, we aren't talking about complex robots with motherboards and microchips. We're talking about everyday, purely mechanical items that help us lift, move, and cut heavy things while requiring a whole lot less muscular effort from us. There are 6 classic simple machines you've got to remember: the lever, the pulley, the inclined plane, the wheel and axle, the wedge, and the screw. I promise you, if you look closely, these 6 basic mechanisms are hiding absolutely everywhere around your house, inside your school, and even right across your local playground. Let's compare 2 specific machines that visually look almost identical: the wedge and the inclined plane. Both feature a flat, slanted surface. But look at their purpose. Now, what's really interesting when you compare these two is that an inclined plane, like a ramp or a staircase, is designed to make it easier to slide or move heavy objects up or down a level. But a wedge, which has that exact same sharp triangular shape like a knife, is forcefully driven into something specifically to cut or split it apart. Same shape, completely different use of force. Let's test that logic in the real world. Why is it easier to chop wood with an axe than with your bare hands? Well, aside from the obvious splinters, an axe acts as a perfect wedge. It takes all the muscular force you swing with and concentrates it into one incredibly tiny area on the very edge of the sharp blade, effortlessly splitting the dense wood apart. It is the absolute perfect application of a simple machine multiplying your effort to do incredible work. And that brings us to the end of our explainer, leaving you with one big, exciting question. Now that you have this complete science toolkit, what amazing things will you build and discover next? You have officially refreshed your absolute mastery of matter, solutions, separating mixtures, applying forces, transferring energy, and utilizing simple machines. You have the essential foundational tools you need to understand and manipulate the physical world around you. So go out there, observe carefully, and start experimenting. Thanks for taking the time to learn with me, and I'll catch you next time.